Okay, so this video is going to go over the notes for the power stuff that was posted yesterday on Wednesday. So today we'll go over the actual notes in class. I'll just go through each slide. Hopefully this helps clear things up. All right, so what is power? So power is defined as how much work do you do in a certain amount of time. All right. We measure power in physics in joules per second, or it's easier just to say watts. And we've all heard of watts before with like light bulbs and things. So that basically tells you how much power is the device drawing. So power's formula is work over time. And think about it, work is measured in joules, time is measured in seconds, hence the joules per second. We use horsepower in America. You don't have to really worry about any of that stuff. But let me show you this. We can also write it like this, power, and instead of saying work, we know work is force times distance, and sometimes even cosine theta, that's all work over t. All right, so same thing. All right, 1 sec. Okay, sorry guys. Here, take this. Okay. Okay, all right. Okay, Google Play, you got A Friend in Me by Randy Newman. All right, continuing on. Power and time are inversely related. And we saw that because power is on one side of the equation and time is on the other side of the equation, and it's in the denominator. So they're inversely related. And we know what that means. If the time goes down, then the amount of power required goes up. So that's what we just said, is the amount of time to perform a task decreases, the amount of power required increases. Power and work are directly related. So if you want to do more work, you need more power. All right, so those are the two things. So here's something that's kind of interesting to think about. If you walk a mile or if you run a mile, your work is the same because you use the same amount of force and you go the same distance. The difference is if you walk a mile, it takes a lot more time, so you need a lot less power. If you run a mile, you're gonna do the same amount of work in a much smaller amount of time, so you need much more power to do that. Okay. So again, if the workload increases and time remains the same, then the power required also increases. Okay, so what do you think has more power, the Camry that might drive or a huge farm tractor? All right, and actually this is not a good question, so let's ignore that one. Let's look at practice one, because this is what I know people got some tripped up on. So a forklift is replaced with another one with twice the power. How much work can do in the same amount of time? All right, so let's think of it like this. Let's draw the equation out real quick. Okay, so if we increase power by 2 times, right? We've always done this before, right? So if we make power twice as much and time doesn't say that time doesn't change, then if power goes up by 2, then work has to go up by 2 to keep everything the same. So we can do twice as much work. If time are not an issue, it really doesn't matter. You could technically do as much work as you wanted to do. Okay, so let's ignore this part. How much a greater load can it lift in the same amount of time? And so greater load would be how much force or work going to do. It's the same thing. You can do twice as much work. All right. Again, if you increase the power by 2, okay, then the amount of work that can be done same amount of time also increases by 2. All right. So sorry about that pause. All right. Let's go back to this. I'm sorry, I got myself all confused with Zoom where I'm at. All right. I am so sorry for the delay. Okay. Sans apologize about the delay. All right. So if it lifts the same load, how high can it lift in the same amount of time? All right, so again, it's all the same idea. It's the same formula. So now, since we're talking about distance, let's rearrange the equation to look like this. Power equals, instead of work, let's do force, distance, time. Okay, so time isn't changing, so we can kind of ignore time. If we double the power, okay, and we're lifting the same load or the same amount of force, then the distance would also have to increase. By how much would it increase? Well, if power goes up by 2 times, then the distance also goes up by 2 times. Okay. And now the last one, if it lifts the same load, how much faster can it operate? Okay, so now we're actually looking at time now. So again, we got power. All right, everything, force and distance are remaining the same, so we're just going to call that work over T. Okay, so if power goes up by 2 times and work doesn't change, okay, buddy, that means the time has to decrease, and it's going to decrease by the inverse of this. So if this went up by 2 times, time is going to decrease by 2 times, or T gets cut in half. Zach, you doing all right? Okay. All right. Let's look at 2. Suppose that the suitcase from the floor to the table, the work you do in the suitcase depends on which of the following. A, the time it takes, the height of the table, or C, okay, the weight of the suitcase. Gotcha. All right, so if we're looking at work, work is force times distance. Oh, too far. Okay, work is force times distance. So which one of these does it depend upon? It doesn't depend on A because time isn't part of work. Does it depend on height? Absolutely. That would be distance. Does it depend on the weight of the suitcase? Absolutely. That would be the force. Okay. For the second part, how about if with power, it depends on everything. Since power is work and time, we know B and C are going to be part of the power equation because they were part of the work equation. But power also includes time, so letter A is also going to be now part of it. Okay. Oh, too far, too far. Oh, so this last one has a guy walking with a car, World's Strongest Man contest. So we'll just do this last part. Don't worry about this horsepower part. The man in the video is moving a 10,500 Newton car a distance of 10 meters in 18 seconds. How much power does this require? So this is just a nice, easy plug and chug equation. We'll write in big, fun spray marker, I guess. So power is work over time. We're gonna have to change this up so it's not as fat. All right, so we're looking for power. Here's the deal though. We don't know work, but we know work is force times distance, or 10,500. That's force times 10 over 18. So if we go and solve 10,500 times 10, well then, can you wash your hands, buddy? We get 5,833.3. And the unit is watts, or just capital W. Okay. So I hope this helps clarify with this. If you have any questions, let me know. We're gonna do some practice tomorrow with more of this. And then that's that. All right, see you guys later.